so let's work through an example of looking at areas above and below the x-axis. So here we're asked, find where the graph cuts the x-axis and the total shaded area for the graph y equals x squared minus 5x plus 4. Okay, so there's two parts to this question. So it's find where it cuts the x-axis and the total shaded area. So the reason we want to find where it cuts the x-axis is that's what gives us our limits of where we're going to do our integration. So you can see here from the graph, we're going to want to do between 0 and whatever that number is, and then between whatever that number is and whatever this number is. And that will give us the two limits, because those limit the shaded areas. So how are we going to find these? Well, it's quite straightforward. You know, this is a quadratic. So all we're going to want to do is factorize this. And we can say that x-intercept at y equals to 0. So you can say x squared minus 5x plus 4 equals 0. So I want something that's going to multiply to make 4 and add up to make minus 5. So that's going to be negative 4, negative 1. X minus 4, x minus 1. So root's going to be x equals 4 and x equals 1. So we can actually put these on here. So that'll be 1, and that'll be 4 there. Cool. So that's the first part done. So now you need to figure out the area of, say, the green part first. I'll switch over to green. So A is going to be equal to the integral between what? Okay, so this is really important here. What are my limits here? Well, my lower limit, you can see, is 0. And then it's going to be positive all the way up to this value here, all the way up to 1. Okay, so it's between 0 and 1. So I say x squared minus 5x plus 4 dx. Cool. Now, is this in the right differential integratable form? Yes, it is. Good. So I can just start straight away. Becomes x cubed over 3 minus 5x squared over 2 plus 4x. Okay, between 1 and 0. Then I can just start to substitute in my limits. So this then becomes 1 cubed over 3 minus 5 over 2 times 1 cubed plus 4 times 1. I don't use square brackets, I use curly brackets, minus 0. Right? So let's see what this works out to be. Okay, just conserving space. So 1/3 plus 2/5 plus 4, or minus 2/5 plus 4. I'm going to stick that in my calculator for the things of time, but you could work it out yourself. So it's 11 over 16. Okay, so that gives us 11 over 16. Or 11 over 6. Anyway. So now we need to work out the bottom area. So this area is going to be equal to exactly the same, but for the sake of time, actually no, I'll do it properly because this is the first time you've seen this example. So this is between, well, what the limit's going to be, the lower limit is going to be 1, and the higher limit is going to be 4. So exactly the same, x squared minus 5x plus 4 dx, right? So then again, it'll just differentiate the exact same way. So this will go to x cubed over 3 minus 5 over 2 x squared plus 4x between 1 and 4. So you can substitute these in. So this then becomes 4 cubed over 3 minus 5 over 2, 4 squared plus 4x, 4 times 4, okay, all in brackets, minus Well, here we can see that we worked out what 1 was, and here we'd just be substituting in 1, so this is actually going to be the same, which is quite handy. 11 over 6. Okay, so if you stick that into your calculator, you'd get 8 over 3, negative 8 over 3 even, minus 11 over 6, which leaves you with 9 over 2 minus 9 over 2, or like 4.5, whatever you call it. Okay, but we're not done just yet because we wanted the total shaded area, right? So we still need to do this final step. Now, even though this area came out as negative, if you remember from our previous lesson, we treat it as positive because we're interested in the total shaded area. We're not worried about the sign of it. So this, I'll change color into something else with good blue. So AT is equal to a area green plus area yellow equal to 9 over 2 plus 11 over 6, which is equal to 19 over 3, or 6.3. Okay, so you can see quickly that these calculations have become quite long, okay, and it's easy to get confused. But the thing to try and do is try and just break it down into little sections, little bits, okay, remembering that you do top minus bottom, and then add them both together. So just the more practice you get, the easier it becomes, but I hope that makes sense.